In this video, we're going to be talking about the use of Red Hat Virtualization as a platform for running Red Hat OpenStack Platform controllers as virtual machines. Whilst this type of configuration has been a possibility for a number of releases, Red Hat OpenStack Platform 13 is the first release in which we have a full end-to-end automation of the virtual machine configuration, the power management for provisioning, and cluster management directly through the virtualization infrastructure, fully supported. We'll be demonstrating this setup over the next few minutes. A lot of the Red Hat virtualization preparation has been taken care of prior to this video being recorded, but we'll briefly highlight some of it now. In this environment, I have 3 physical hosts, which would be the minimum number of physical hosts that we would recommend for production use. Whilst it's possible to leverage a smaller number of hypervisors, this doesn't give you any form of guarantees when it comes to recovery in the event of a system failure. Your OpenStack cluster could shut down in the event that you lost a single hypervisor that was running more than just one OpenStack controller virtual machine. One of the primary benefits of virtualizing your control plane is to allow you to add additional virtual machines such as Red Hat Satellite, Red Hat Ansible Tower, or Red Hat CloudForms to the same set of physical machines, driving up system utilization. What we've done in this environment already is to pre-configure a set of virtual networks that we're going to be attaching to our OpenStack controller virtual machines. These networks are VLAN based and reside on an LACP based set of interfaces, and they correspond to the usual set of OpenStack networking traffic types that we might consider in a typical production environment, such as internal networks for inter-OpenStack communication, a storage replication network, a public network for routing in and out of your OpenStack-based instances, and various others. In addition, we have a dedicated provisioning network called OSP Provisioning, which OSP Director, which is our OOO-based deployment lifecycle management tool, will use to automatically pixie boot and deploy our OpenStack infrastructure later down the line, but this is not currently part of the bonded interface. Within this environment, we already have 3 virtual machines running. One is the self-hosted Rev Manager, known as Hosted Engine. We also have CloudForms, and we also have an Ansible Tower virtual machine. We're basically demonstrating here that we're able to leverage the same set of hardware to run more than just the OpenStack controllers. So let's start deploying our OpenStack infrastructure, noting that because we're using OSP Director, we will first need to deploy our undercloud, which is the command and control cloud that's used to bootstrap the overcloud, where our production cloud would run. Red Hat has been working on an Ansible-based automation tool to deploy all of the required virtual machine structures, as well as automate the installation of our undercloud based on a set of parameters that we can feed in. Here you can see that I've specified a configuration file which is YAML formatted that lists everything I need: the location of the Rev API, some credentials to use, the specifications including MAC addresses and IP addresses I want to use for my undercloud machine, some subscription manager details so my systems can be automatically registered to the Red Hat Content Delivery Network, and finally all of the configuration options for my undercloud. We're essentially advising how the undercloud should be deployed and what networks it should use to do so. What we do here is execute the Red Hat provided playbook and advise it of the location of our configuration file. After a few seconds, you'll see that the playbook not only defines the undercloud VM in Rev, but also 3 dedicated OpenStack controllers too that will be used at a later section when we deploy our overcloud. The eagle-eyed amongst you will also spot that we create a virtualized compute node too. This is purely to help us demonstrate a fully functional OpenStack cluster as part of this demonstration, and not because it's a requirement. It's fully expected and fully supported that customers will utilize physical compute nodes as per usual. Mixing and matching virtual and physical infrastructure is possible and fully supported with Red Hat OpenStack Platform 13. Over the next few minutes, the undercloud machine will have a number of required packages installed, and the undercloud configuration file will be written out so we can begin the installation process. Now we've got to the point where it's running the undercloud install step, we can jump to the machine directly to monitor the undercloud installation progress by tailing the undercloud installation log. This process takes a few minutes. Remember that it has to install OpenStack from scratch here. It also has to ensure that all the services are started correctly. For the sake of time, this section of the video is sped up considerably. And there we go. Undercloud installation has been completed successfully. Whilst our playbook executes some additional tasks to help prepare for overcloud installation, let's ensure that the OSP Director web interface has also been configured for us. Okay, looks good. If we switch back to our playbook, we'll see that it's carrying out a number of additional tasks, such as importing the overcloud images, registering the virtual machines that will become our overcloud nodes with Ironic, OpenStack's bare metal as a service component, enabling the correct driver so that Ironic can communicate with the Rev API to do automated power management, and finally kicking off an inspection of our overcloud nodes. What the inspection process does is gather system metrics and will optionally benchmark our target overcloud nodes to ensure that they've been configured correctly and are operating within the correct parameters. The added bonus of doing this at this stage is to really ensure that the power management and PXE booting is working. So it tests all of the underlying plumbing to make sure that our networking configurations and power management functions are working as expected. If we switch to another terminal and ask Ironic for the status of our virtual machines, you'll see that they first start off in a power off state, but after a few seconds they're automatically powered on by Ironic. And we can see this reflected in the Red Hat Virtualization user interface too. After a minute or so, these machines will have completed their inspection process and will be powered down automatically. At this point, our playbook will exit, as it will allow for us to configure the overcloud as per our requirements. What we'll briefly do now is ensure that our inspection process collected the right information about our systems. If we ask Ironic to show the information from controller 1, it tells us that this machine has circa 50 gigabytes of memory, 60 gigabyte of disk, and 16 CPUs. It's also possible to get this information from the user interface for OSP Director, noting that we will first have to grab the randomly generated password in the stack.rc file. So that's showing the same information here. If we go back to the Red Hat Virtualization user interface, we can also see that it matches with the true specification of the machine as configured by the playbook initially. Now let's move on to the next major step, which is deployment of the overcloud itself. The purpose of this video is to also demonstrate the cluster working as expected. And to do that, there are a number of additional steps that we need to take care of. Since OSP 12, OpenStack services have been containerized. So this step downloads the required container images into a local registry that we've actually had set up by the undercloud. This is a two-step process. Firstly, we specify a list of the images we need based on our desired configuration. As I'm sure you can appreciate, customers have a wide variety of different configurations and different backends. But in our case, this is a very simple and straightforward vanilla configuration. Then, secondly, we upload the container images to the registry itself. This generates a configuration file that we'll use as part of our overcloud deployment so the controllers know which images to download and from where. In our case, that is simply the local image registry that runs on our undercloud machine. Let's now look at our deployment templates, noting that given this is meant to be a very vanilla configuration, our setup is somewhat basic. I've defined a template that sets the majority of the configuration. Firstly, defining the network setup for each machine. ensuring that the virtual controllers, and in our case, the virtual compute, are attached to the right rev networks for each network traffic type. Then we move on to define how many of each node we require. So in our case, that's 3 controllers and 1 compute. We define a number of other parameters that help set things up, like the LACP configuration, various environment-specific IP addresses, and the VLANs that we're using underneath. Next up is a template file that defines all of the networking configuration in terms of the IP address allocations that we use for each network traffic type. Defining networks in this file is part of the composable networking functionality that was enabled in the previous release, OSP 12, and is a requirement in all versions from OSP 13 and beyond. For example, we have the storage and storage management networks, and more importantly, we're highlighting here the external network, as it's relevant to demonstrate the IP range that our OpenStack infrastructure is going to be deployed on from a public perspective, and how we're going to interact with it later down the line after deployment. Now we have our templates ready, we need to only make sure that our nodes are in a available and power off state, which we can see that they are. At this point, we're ready to kick off our overcloud deployment, noting that the most common thing to do here is to perform a number of automated validations through OOO directly or via the web UI. This basically ensures that everything is working correctly, and we've done a number of pre-flight checks. But in the interest of time and to keep things simple, we'll assume that everything is in order. We can use the overcloud deploy command to specify our template files that set our required configuration, our network setup, and the template that defines our container images, the files we basically showed you a few minutes ago. This process of overcloud deployment will typically take around 30 to 40 minutes within this environment, which obviously depends on the desired configuration and, of course, the hardware specification of the environment, but we sped this up considerably for the video. If we watch the output from Ironic, we can see the nodes changing state between deploying, where OSP Director will provision a Red Hat Enterprise Linux image onto the virtual controllers, and then go to active when the machine has been successfully provisioned and is then ready for OpenStack software installation and configuration. During this time, the machines are automatically powered on through Ironic's control of the Red Hat Virtualization API, and are set to Pixie boot on our provisioning network that we have already configured. This process goes through a number of different deployment steps, where container images are downloaded, services are configured, started, and tested. Here you can see that we paused the video on step 1, but there are a total of 5 steps before the process finishes. Finally, the overcloud has been deployed and should be ready for testing. For convenience, I've written a test overcloud shell script that calls a number of common OpenStack API tasks that will enable us to ensure the main functionality is working as expected. We upload a RHEL7 disk image. We create a number of networks, both an external network that corresponds to the public network we defined earlier, as well as a VXLAN-based overlay network that will attach our instances onto. It also creates a router along with security group rules so we can test any instances from the networking perspective. Creates a dedicated key pair for passwordless access, and then it finally creates an instance. Whilst the instance is booting, it will create a floating IP and then attach it to our instance so we can try and connect into it afterwards. Let's now run that script and create the resources we need to do our testing. Okay, so our virtual machine is now started, noting that in a real-world scenario this would be on a dedicated physical machine, but here it's a nested virtualized machine and therefore performance will be pretty slow, but it suffices just for doing some testing. OpenStack Nova outputs the status as active and outlines the 2 IP addresses that it has allocated to our virtual machine. We're mainly concerned with the external IP, as that's the only one that's routable for us on this particular machine. Our first test would be to ping the IP. If this works, we know that networking has been configured properly. Looks good from that front, but what about Secure Shell? Let's verify that we can also connect over Secure Shell as well. Connection refused. That's actually a good sign. It proves that networking is up, but perhaps the machine hasn't quite fully booted and the Secure Shell daemon isn't running yet. Okay, third time lucky. But let's use the right username here for the RHEL 7 cloud image. So we're able to successfully launch an instance on our overcloud. Networking is functioning. You can see that it only has the internal overlay network address as per usual, and that security groups are obviously granting access based on the rules that we ask for. At this point, let's see our resources as configured within the OpenStack dashboard for the overcloud. We'll first have to grab the admin password that was randomly generated by the overcloud installation and then log in. If we navigate through the dashboard, we can see our instances being created. We can also see the instance's console log. And then we can also directly connect to the VNC console of our running instance. Again, we're simply verifying this is the same instances we just connected to over Secure Shell. Finally, we can clean up the environment. And that's it. Thank you for watching. Please do get in touch with your Red Hat account representative if you have any further questions or want to learn more.